Okay. Glad you all could make it to the studio review. Fair warning, this studio was long, so I'm going to try to get through as much as I can with the time that I've got, but I think it's fairly unlikely that I will get through all of it. The good news is that Wednesday is a catch-up day, and I wanted to do the enumeration exercise that I didn't have time for last week or the week before. But anything that we don't get done tonight, I can do during the catch-up day on Wednesday as well. So let's go ahead and get started. Got a lot of ground to cover. So let's see how far we can get. First thing they want us to do is to make a new schema called Movie Buff. So let's go in. We saw how to do that during the exercise. So make a new schema, movie-buff. Shows me the query again. That's nice. I'll go ahead and do that. And then remember that we have to refresh over here. Or maybe we didn't. It's right here. Movie Buff. Was it there before? I don't know. Maybe it was. Maybe it wasn't. But it's there now, which is what matters. And now we're going to create a couple of tables, one for movies and one for directors. And this time, they do give you some code, right? But I hope you took this seriously and thought about these questions that they ask you regarding the data types for each of the columns within your table. So, you know, the movie ID column that they talked about, I mentioned during class today. I mean, your primary key column is probably almost always going to look fairly similar. So if I wanted to start setting up a create table statement for directors with my primary key column first, it's probably almost always going to look like this. It's just such a standard way of doing primary key columns these days that I can't even remember the last time I did anything different for a primary key column. So that one you don't really have to think too hard about. But the other ones do require some thought. For things like title and director, I think that strings obviously make sense, but then what sizes should they be? That's really the difficult question that you now have to ask yourself with strings. I don't know if any of you talked about this during the studio or if you have any ideas. If we kind of cheat a little bit and look down here, we can see the sizes that they chose were 120 for the title and 80 for the director. Does that seem reasonable? Oh, wait, that's for movies. I'm sorry. I'm supposed to be making the movies table. I was making the directors table. I'm sorry. But the question still stands. Do these lengths seem reasonable to you? I think most people would probably suggest that these seem a little bit large, but it's much better to have a column that is too large than one that is too small. The last thing that you'd want to happen is you insert a new movie and it tells you can't because the title's too big or the director is too big. So that's why those were chosen to be so large. Anybody can tell me a movie that's 120 characters long. I'd be interested in that information. The year I think they chose was an integer, which is cool. And then the director they chose as 80. So this is, I think, what they suggest. Oh, year released. You can see that year is actually a keyword. It turned blue. That's why they changed the name of it a little bit. Did anybody deviate from this? Did anybody feel strongly about? Do I want to click on this link? Let's see. Longest movie titles. Oh, nice. See, this Night of the day, of the dawn, of the son, of the bride, of the return, of the revenge, of the terror, of the attack, of the evil, mutant, hellbound, flesh-eating, subhumanoid, zombified, living dead, part 3. Wow. Oh, and there's a part 5. Yikes. This is quite the list. Anyway, was that 120 characters? I'm not going to count them. I'm not going to count them. But definitely better to plan for more space. 4.2 stars. Yeah. All right. Did anybody deviate significantly from this, or want to make an argument that any of this is not reasonable or confusing? So I'm about to make a mistake, but I'm going to go ahead and do it anyway on purpose. I click this button, right? And then I go here and I hit refresh and I say, where's my table? And wait a second, it's not here. It's not here. It's up here in the schema that I was using during class today, because I forgot to double click this to indicate that that's the schema that I want to use. See how it turned bold after I double clicked it? Whoops, I made the table in the wrong place. That's okay. Double click it, recreate it in the right place. I'm certain that there are probably some of you that did that as well, perhaps. But now we've got the table created in the correct place. And we can shift our focus to the directors table. So same kinds of questions to consider. First name, last name, and the country. And we also need a primary key for our directors table. So just change the name of this. First name, last name. I don't know. 120 characters, that seems a bit much, right? Is there a list for the longest names of directors? Somebody's furiously Googling it right now. So here's what they suggest, and that's kind of where I ended up as well. It seems pretty reasonable, right? If we were making a Java object, this is pretty similar to what I would expect the Java object types to be as well. String, string, string. And so we'll go ahead and create this table as well. Make sure that it's there. There it is, directors and movies. All right. The next thing that it talks about is something that I touched upon very briefly in class today, but didn't go full bore into it. They're kind of pushing the issue a little bit and giving you kind of a sneak preview of what's coming up next week during next week's class. There is a way to make tables connected to one another, or we'd say to make them related to one another. You may hear a SQL database referred to as a relational database, and that's why. It's because we can make relationships between tables. We're basically creating a link between those tables. And one of the big reasons why we like to do this is what this text is explaining is it allows us to eliminate a lot of the redundancy that we might expect. So if I had put, the director information into the movies table, for example, which I certainly could have done. I could have put, director name, director country in my movies table. But what's going to happen when you get a guy like, Steven Spielberg, who's directed, I don't even know how many movies over his career, a lot, right? A lot of them. His name is going to show up many different times, once for each movie. If I cram it all into one table, that director information is going to show up multiple times. That's a problem. It takes up more space than we wanted to. It allows mistakes to creep in. What if I misspell his name in one of the movies, in one of the records? Then it's not going to match the other records, and I may not find the information when I go looking for it. So it's really best if every piece of data in the database is stored in exactly one place, and then we just refer to that piece of data when we need to. We make a connection, and that's what they have us doing next. Instead of having directors crammed into the movies table, we've got a separate directors table, and we're going to make a link. We're going to make a link between the directors table to the movies table. And we can even specify what kind of relationship this is in English. One director can direct many movies, right? And so we would say that this is a one-to-many relationship. That is how we classify those relationships. One director can direct many movies, one to many. So one row in the director's table may be linked to multiple times in the movies table for every movie that director has directed. And so in order to reflect this relationship, we need to change our structure a little bit. We need to change the structure of the tables a little bit. Instead of having in the movies table, instead of having the director be a string, presumably the name of the director, instead what we could do is have a reference back to the director's table. In other words, every director has a primary key associated with it, correct? Whoops. Directager. Every director has a primary key associated with it. I can take the primary key for Steven Spielberg and tack it on to every movie that he's ever directed. And then what do I need to do if I want to look up, E.T. in my movies table and I want to know who the director is? I look at that number. I go back to the director's table. I say, I find that number in the primary key column, and that's going to lead me to the Steven Spielberg entry in the director's table. That's a join. That's how a join works. That is exactly what we use joins to do. So we want to change the type of I did it again. We want to change the type of the director column and the name actually in the movies table. And in order to do that, we're going to need an alter table statement. So we need to use the director ID, which is a number. So we need to change the type and we need to change the name. Oh, well, I guess we can't use an alter. We could use an alter table statement to change the type. They're having you drop the movies table and recreate it all together. Is that necessary? I feel like there's another way you could do this. I feel like you could drop column director, right? You could drop column director. I'm deviating from the script now just to kind of see if I can. All right, so now the director column is gone. It is. Now we will add a column director ID, which is an integer, and it references director ID. There we go. Which looks very, director is plural, which looks, very similar to the syntax that they have us using down here, right? I think this will get us to the same place. Let's see if this works. Cool. It looks like that it did. If we want to check and see if it worked or not, we can use the schema inspector. That's not what I was looking for, actually. Shoot. Thought there was a way to visualize. Load spatial data. No, that's not what I wanted. Sorry, I thought there was a way to visualize the schema. Is there not? Yikes, that's a lot of steps. Reverse engineer, huh? Movie buff. Okay. Well, it almost worked. Here's a visual representation. It actually didn't add the foreign key, though. Dang. Didn't add the foreign key. So I got very close. I feel like I probably could have figured out how to get that foreign key on there. Shoot. Feel like I was close. Anyway, sorry for the tangent. I was just trying to see if I could. I think I could do this actually. Add foreign key. Well, let me do that. Director ID, references, directors. Parentheses, like this. Let's try that. Ah, shoot. Failed to add the foreign key constraint missing, column, director ID. Maybe that. Shoot. No, I don't think so. I don't think so. Alter table, add constraint. I missed a line. Yep. Add constraint, foreign key, movies, directors. There. Sorry. No. Let's take this out. Alter table name, add constraint name, foreign key, this thing, references, this thing. Thought that's what I did, but I can't get it to work. And I'm digging myself into a hole. Oh well, I tried. That's gonna bother me though. Why doesn't that work? Oh, I didn't even need that line. This isn't even required. I could have just said add. That didn't work either. Missing column director ID. I don't know what you're talking about. Did I spell it wrong or something? Anyway, I'm going to move on just because I don't want to get stuck in a hole. Sorry about that. So yeah, regardless of how you got there, that's how you can add a foreign key. We're going to talk about that more on Monday. And then in order to actually have some data, we have this data set for you to use here. We're going to download it. Unzip it all. Yeah, and then in here we can do open the script file, go find this thing right here. We can see it's just a file filled with insert statements, and I always remember to go down and put the L in this movie because they made a typo. It drives me crazy. And now we should actually have some data. There's a bunch of there's a bunch of movies. And here is a bunch of directors. Okay, so once we have gotten all of that done, we can spend our last few minutes writing some queries. So we're not going to get through all these in 5 minutes, but we'll do as many as we can in 5 minutes, and then I'll do the rest on Wednesday during the catch-up day. List just the titles of all movies in the database. They're starting us off with kind of an easy one, right? Remember, if I'm getting data out, I always like to... It does, yeah, but changing all of that would take too much time. It does annoy me, yes. So we want to select title from movies, right? They start us out with a pretty straightforward one. Here's all the titles of the movies that exist in the database, right? Let's try some more complicated ones. List the title and year of each movie in the database in descending order of the year released. So we can kind of use our last command as the basis of this one. Order by year released, descending. And if you want to, you can include year released up here as well. Like we talked about during class, it's not strictly required, but Toy Story came out in 1995. Man, that makes me feel really, really old. Cool. Let's see if we can do at least a few more of these before we run out of time. List all columns for all records of the director's table in ascending alphabetical order based on the director's country of origin. So they make this sound a little bit more difficult than it is, right? Where if we want everything, that's just a select star from directors. And now we want to do it by country. And if we... This is a thing that you can do, ASC, for ascending, but it's not necessary. If you don't put anything after your order by, it does it by ascending automatically. And we can see that it works. M's, N's, ST, and then U. I've got time for a couple more, probably. Order by can also consider multiple columns. So all columns for all records in ascending, and then director's country of origin, and then by the director's last name. That's actually a very simple addition. We just do last name right here. We saw something similar to this during the prep work today as well. So now we see that if they're from the same country, like these American actors are, it then sorts by last name. All right. Let's see. Where are we at here? We've got, excuse me, we've got a few left. You know what? I think I'm going to call it. I think I'm going to pick up with the rest of this studio during the catch-up day on Wednesday. So I will stop here with number 5. Remember to pick up with number 5 on Wednesday. So if you have any questions, I can stick around for a few minutes. Otherwise, enjoy the rest of your week and let us know how we can help you on the homework assignment that's due. Thanks, everyone. See you on Wednesday. Yeah, thanks. Have a good night.